Now, in 3.2, we are asked to find the value of p when these two sums are equal. So we are given that the sum to infinity when k is equals to 1 of 27p to the power of k is equals to the sum of 30 terms when n is equals to 1 of 3 into 1 over 2 to the power of n minus 1, right? So what we're going to do is we're going to first find the three terms of this sum to infinity so that we'll be able to identify the sum of the sequence, the sum to infinity. So first find the three terms for this one, and then for this one here, if you take a look, it's actually similar to the previous problem that we just did. If you look at this portion here, so you don't need to find the first three terms because we already know them. We know that it's equals to 3 over 2 and 3 over 4, and our r we found to be 1 over 2. We already know our r, we already know our a, which is equals to 3. So, and what we need to note is we will find our n very easily because n is equals to top minus bottom plus 1. So n is equals to our top value, which is 30 there, minus our bottom, which is 1, this portion here, plus the 1, so it's going to be 30. So we have everything for this side, and let's just find the first three terms of this one here. So it's going to be when k is equals to 1, 27p to the power of 1 when k is equals to 2, 27p to the power of 2 when k is equals to 3, 27p to the power of 3. Right, we are substituting the k to this power here. So our first three terms of this sequence is going to be 27p plus 27p squared plus 27p cubed, right? So our a value is equal to 27p, and then our r, because this is a sum to infinity, our r is going to be 27p squared over 27p equals to 27p cubed over 27p squared. So our r here is going to be p because the p will cancel the p, remain with p, and the 27 will divide out. So your r is equals to p. So now to find the sum to infinity, which is equals to a over 1 minus r, our a value is the 27p, so it's going to be 27p over 1 minus our r is equals to p. So this would be your equation 1, the sum of infinity, right? And let's deal with the other portion. Remember that our sum here, we already know our r being equals to half. We calculated our n, which is 30, and we know our a value, which is 3. So we know very well that we are dealing with a geometric sequence, right? So to write that down, we have r is equals to 1 over 2, a equals to 3, and n equals to 30. So to find the sum of this geometric, so what you're going to do is you're going to say sum of 30 terms is equals to a. So to find the sum, we first write the equation of a geometric. So it's a into 1 minus r to the power n divided by 1 minus r. So the sum of 30 terms is equals to our a value, which is 3 into 1 minus into 1 over 2, which is our r to the power 30, divided by 1 minus 1 over 2. So if you punch your calculator, you're going to get an answer that approximates to 6. So simply write 6. So s of 30 is equals to 6, and sum to infinity is equals to 27p over 1 minus p. And remember that these two sums were said to be equal to each other. So meaning that you're going to say the sum to infinity is equal to the sum of 30 terms. So we want to find the value of p. Remember that. So the sum to infinity is equal to 6 equals to the sum of 30 terms is 27p over 1 minus p. Then we cross multiply, is going to be 6 into 1 minus p equals to 27p. So we're going to multiply the 6 inside here, so it's going to be 6 minus 6p equals to 27p. Transpose the minus 6p to the other side, you have 6 equals to 27p plus 6p, right? And then 6 is equals to 33p, and then you divide the 33 both sides, you have p equals to 6 over 33. So if you simplify, it's actually 2 over 11. So this is your value of p. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.